everybody is live now in YouTube.
बस होम स्क्रीन चेंज करो बेटा, फिक्स करो. Start the Ishre tunes and अपना videos please. Start the Ishre tunes and अपना videos please.
We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence.
We are experiencing a technical snag. Please give us a minute to reboot it. Just give us 1 minute.
We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal distributing the wealth of knowledge to all its members. Working with government departments, ISHRE helps formalize industry codes and standards. ISHRE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrex India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions among the decision makers in the industry. The Acrex exhibition is now growing from HVAC&R show into BFA, Air Alliance. This brings together several allied shows connected with the building services industry, all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRE to catalyze the transformation of the budding engineering professionals. ISHRE provides a platform to potential employers to select student members for careers in HVAC and our industry at the ISHRE Job Junction. Young minds are made aware of the need for saving power, clean air and sustainability. The K-12 initiative of ISHRE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, and energy efficiency and conservation, to enter and explore the universe of the Indian HVACR industry. Log on to ishre.in that unfolds a panorama of information. Let us engineer a sustainable future together through ISHRE.
Warm welcome to all our guests today, and thank you so much for joining in. These are troubled times, and I pray that all of you are safe and your family is safe as well. Today is a special day, not only in terms of that we are celebrating the World Earth Day, but also that we are today having two wonderful, or maybe three wonderful, programs that are happening right now in this program itself. A lot of knowledge sharing. I will not be too much between you and the program. I am Ashish. I am the president-elect for DCI. Just two things that I just came to me as I was going through Google and WhatsApp. So there's a perspective that I would just leave with you. So अगर आप Google करेंगे, the age of Earth, so it'll probably give you a figure of like 4.543 billion years. And if you Google and see what is the age of human beings, then it'll give you something an age of like Homo sapiens, about 2 lakh years. Now, if you were to, put this perspective in a time frame, probably, into days, minutes, and seconds, it'll be, very important to understand that on the Earth life cycle, the impact, the human sapiens, human beings have been for about 3 seconds on a 24 hours basis. And in 3 seconds, the kind of damage that we have done to this Mother Earth is unimaginable. And it is only by the concentrated efforts like the ones that we're going to talk today, and then sensitizing everybody towards cleaner, greener Earth, that we will, as a humankind, enter into the 4th second on the time life cycle of Earth. तो हमने 3 seconds में जितना खराब किया है, उसको अब अगले 1 second में हमने better करना है, ताकि हम और हमारी future generations they can enjoy. Today, as a part of the celebrations, we have asked all our DCI members, past, present, to contribute a photograph by doing something to, celebrating the the Earth Day today. And I would request that if our backend support team can play the video and the PPT to show what everybody did, just to set the tone right for the day. Tapas, can you play, please? So this is a small presentation on what all of us हम सब ने आज जो मिलकर किया है. Thank you so much for everybody in participating in making the earth green. Today is a wonderful day. We have Dr. Varun Jain, who is going to lead us to the idea of carbon neutrality. And then we have Mr. Madhusudan. My special thanks to Madhusudanji, because today he has been reported as COVID positive, and despite the fact that he has a sore throat and he's not really very well, he has still continued to do the program for all of us. So thank you so much, Madhusudanji, for doing this program with us. Also, I would like to take this opportunity to thank our sponsors and partners, the annual partners. We have our gold partners as ALP Aeroflex. Then we have Standard, Advanced Valve, Fluke, Luby, Lloyd Insulation, and AEPL. Thank you so much to the sponsors for making this event happen. Now, I would like to leave this August gathering with Dr. Varun Jain, and it is my honor to just to introduce him. I don't know if anybody in the group doesn't know him, but still, for the benefit of my privilege, I would like to read a little bit about him. So Dr. Varun Jain is the immediate past president and student chair for ASHRAE India chapter. He holds a bachelor's degree in electrical and electronics engineering. He attended a 6 months professional design engineering training in air conditioning at Wisconsin, USA in 1997. He obtained his MTech degree from IIT Delhi in 2000. He worked 2 years in California, USA, and after returning from USA, he involved himself in research as a PhD student for Center for Energy Studies Department at the IIT Delhi. He is now working as Director Technical in one of the leading building services consultancy firm, Sanelec Consultants Private Limited. He is a certified energy manager cum auditor by BEE, Ministry of Ministry of Power. He's been associated with HPS industry since 1996. He is the founder of a startup of MEP A to Z LLP, and this startup is in the field of training and placement of graduate students. He's a member for, as I said, he's been past president for ASHRAE. He's member for Association of Energy Engineers, AEE USA, Chartered Institution of Building Service Engineers, London, Society of Energy Engineers and Managers. So Indian Society, ASHRAE obviously, and Solar Energy Society of India. It's my great privilege to welcome Dr. Varun Jain, and I would leave this August evening in good care of Dr. Varun Jain. Please, Dr. Varun Jain, thank you so much.
Thank you, Ashish. And you rightly said that in 3 seconds we have damaged the earth a lot. I hope I am audible.
Yes, sir, you are perfect, and the video, the PPT is also perfect. Please go ahead, sir.
So I was asked to give an introduction to carbon neutrality, and I spoke to a couple of people, and they said they understand what is net zero energy. But in carbon neutrality or zero carbon footprint, do we remove all the gases from the atmospheres like methane, CO2 and all? So I thought, let me start my presentation with that we all know what is net zero energy. Net zero energy is total amount of energy used by the building on annual basis and the total amount of renewable energy produced on the site. Now, what is carbon neutrality is? Carbon neutrality is the sum of all the greenhouse gases that is emitted into the atmosphere, and equal amount of CO2 removed from the atmosphere should balance out to zero, also known as a zero carbon footprint. You have to see that we are emitting greenhouse gases, which are many, but we are only removing CO2. So to achieve carbon neutrality, we need to reduce not only CO2, but CO2e. Now, what is this CO2e? CO2e means carbon dioxide equivalent, which is the standard unit of carbon footprint. Now, let us understand what is CO2 carbon dioxide equivalent. So the idea is to express the impact of each different gases in the equivalent amount of CO2 that would create the same amount of warming. So to understand this, let us, for an example, in 2009, UK released 474 billion tons of CO2. Now, but if you include its emission of other greenhouse gases such as methane, nitrous oxide, etc., the country's total emission works out to be 566 million tons of CO2e. That means the extra gases that is added, the equivalent amount of 92 million extra ton of CO2 needs to be removed to reduce global warming. So it is a way that carbon footprint consists of lots of different gases and can be expressed as a single number. We all know what is greenhouse effect. In desert, snow desert, a glass is created to grow plants and vegetables. Now let us understand the greenhouse effect of the Earth, planet Earth. Now all the sunlight which is received by us goes, some becomes as a heat and some goes back to the space. The greenhouse gases prevent this heat escaping from the space and warming the planet so that we have a livable temperature. Now let us assume that there is no greenhouse gases, then what would happen? The Earth's surface temperature would have been minus 18 degrees centigrade, which is not a livable temperature. Now this naturally occurring amount of greenhouse gases keeps our planet livable. So we need some amount of greenhouse gases which is naturally occurring. Now by holding on to some of the heat energy so that it does not escape in the space, the heat trapping known as greenhouse effect. After industrial revolution, the greenhouse gases has increased in the atmosphere, which is a major problem. Too much of greenhouse gases makes Earth too warm. That is a major concern. Now assume that this glass enclosure is like greenhouse gases. Naturally occurring greenhouse gases will keep the Earth warm. But if we keep on increasing the greenhouse gases, the temperature will keep on increasing and the glaciers will melt, the sea level will rise and many of the islands will vanish. So how to achieve it? In order to limit global warming to less than 1.5 degrees centigrade, the emission needs to be net zero by 2050, or to limit it to 2 degrees centigrade in this century, by 2070, the emission needs to be net zero. There is no single path to limit global warming to 1.5 or 2 degrees centigrade. So we need to use renewable energy in combination of energy efficiency to achieve carbon neutrality by 2050. And we hope that the entire world participate in this and reduces the greenhouse gases so that we can say that the carbon neutrality is achieved. Renewable energy would become the dominant form of electricity generation, such as solar energy, wind energy, bioenergy. But the challenges with these energies is that solar and wind power is a key challenge in this intermittency and the variability. Bioenergy's combustion is required, which releases greenhouse gases. Now, still it can be considered as carbon neutral because the carbon that is released during combustion has previously been taken from the atmosphere and will be absorbed again by growing more plants. So it is the carbon which we take from the atmosphere and that same is released by growing more plants. This is one slide which gives on y-axis the amount of CO2 emission. On x-axis, it tells that from 1800 till 2017, which country has more polluted or damaged the earth. So if you see, Australia and United States, both are developed countries and they have damaged the earth maximum. If you see, India is the lowest at present. China, you see the curve is rising from 2000 to 2070 because they have reduced the poverty to nil. And to reduce the poverty, you need to have more industries, which releases lots of greenhouse gases. So India has a challenge because if we need to reduce the poverty without increasing the greenhouse gases, then it's a big challenge for our country. The same site gave me one map, which you can see the red areas are the developed countries, Gulf area, and these areas which have created maximum CO2 or emissions in the on this planet. This is one of the picture I got on WhatsApp. I thought to add this. जब पानी बिकना शुरू हुआ था, तब हमने मजाक समझा था. आज हवा भी बिकना शुरू हो गई है. Now, what Ashish had said in 3 seconds, we have damaged the earth, and it is this picture is depicting the same. That when we were young, we had I had at least never heard about air purifier or RO water in the kitchen, RO system. So we had air for free. And even I remember my grandmother used to put that channa in the tap, and that used to be the filter. So the water pollution was also not there. So life we are giving to our future generation is that if we keep on polluting the planet, they will be with oxygen cylinder and the mask. So let us take a pledge on Earth Day to conserve the climate so we can give our future generation a life that they deserve. Thank you. Now I would request Mr. Madhusudanji to deliver the main theme of this webinar, which is path to carbon neutrality using solar thermal solution. And let me just give his brief introduction. Mr. Madhusudanji is the founder and MD of Urja Energy. His expertise is in clean tech, heating, cooling, and ventilation solution. He has 4 patents filed in these fields. He is a pioneer in introducing many new technologies at a commercial scale in India. These technologies include radiant cooling, geothermal cooling, solar and waste heat based cooling. He has been at the forefront of promoting low energy and healthy buildings in India. He holds a bachelor in mechanical engineering and has a professional degree from Terry University and Stanford Graduate School of Business. He is currently the chair of technical group on radiant cooling in ISRE and is actively involved in various R&D and activities in the space in India. Thank you. I hand it over to Mr. Madhusudanji.
Thank you for the kind introduction, and happy Earth Day to all, and a big thanks to ISRE Delhi chapter, especially the organizing committee, for having me as a speaker today. So today, normally we all talk in ISRE presentations. Usually, even I am talking about buildings or something related to buildings. So my presentation or talk today has very little to do with buildings, and I'm going to talk about we are pursuing as a country, as a world together, we are pursuing various paths to carbon neutrality. I am going to talk the areas that we are missing and how solar thermal fits into that area. And then towards the end of it, I will introduce a topic related to hydrogen as a path to carbon neutrality. Okay. So with that, taking further from Varunji, so these are the commitments that India had made. That one is unconditional target. We said by 2030, we will reduce our emissions intensity of GDP by 30 to 35% below 2005 level. Now, this is a very, cleverly worded target we have put, because we are not committing to anything in absolute, right? So this is something that I think was done on purpose so that we don't have to commit something on an absolute number. But having said that, in the next slide, I'll tell you where we are on that. The rest are mostly conditional targets, which means we can try to achieve them. And the biggest of them is in the power generation, the non-fossil share of power will be at least 40% by 2030, right? And other one, which is LUCF, which is land use change and forestry. We are supposed to create a carbon sink of 2.5 to 3 gigatons of CO2 equivalent, which, as it was explained earlier, combines all the GHG emissions also by 2030. So anyway, in terms of long-term goals, per capita emissions as you had seen in the graphs presented by Varun Jain, that we are way below, and I don't think we will ever exceed that in terms of per capita, because we have a lot of population. By 2030, I think we'll be around 1.5 billion. So the per capita, we would be fine. But where do we stand today in 2021? So these are the numbers for 2020 actually. So in terms of emissions, now this is the COVID effect that you see, that we were almost just below, but there is enough gap now. We are close to around, I think, 2.7 billion ton of CO2 equivalent. And if we continue this path, the blue path that you're seeing, we would be, what is projected is even by 2030, we should be able to achieve our unconditional target, right? So that is where we are. As far as 40% of the power generation being from renewable or non-fossil sources, we will reach there much ahead, maybe within a few years, and beat that by a good margin. So we are fine there too. The biggest concern actually is the green line that you see is actually the sort of the forest cover, where we have committed 2.3 to, what was that, 2.5 to 3 gigatons of CO2. We are nowhere close on that. So this is our biggest Achilles heel. So I was happy when I saw the pictures of everybody planting trees in their backyard, on their roof, because this is what we lack today. And though Government of India also has, I think, a big program, Green India something, which is expected to at least cover half of the target. The rest is on people like us and businesses, private entities, to see that we achieve that target. Okay. Now, the reason why that is important is if you take this out and you still continue to do this, there's not enough zinc to absorb this, right? I mean, we are saying from 2011, but compared to 1990, it is already 400 times, right? So we need to have this carbon sink, because if we compare it to 1990 or 2010 levels, our emissions are actually increasing. Okay, so it's just a play of numbers. We'll have to keep this in mind, and that is why a lot of attention is needed here. However, I mean, that's not the topic of discussion today. So I will go to see what are the major paths to carbon neutrality. Before that, let's see GHG emissions by sector. Now, fugitive emissions are very small. If you see the transportation sector here, quite big, but we are addressing it using electric cars, right? So though the uptake has not been, as desired by the market, I think it is inevitable that we will get there. The prices have to drop, but we have a path. We at least have a path to that. There is other fuel combustion. I don't know about that, but manufacturing and construction is a major one, where embodied carbon in the industrial processes is a major issue, where in the building scenario we are looking at now, in many cases, how much is the embodied carbon for all the materials that we are using to construct, not just the energy efficiency or how much energy we are using. Now, one thing that is falling through the sieve, right, is when you say electricity. So this is the biggest chunk that you see here. This is the biggest contributor to the GHG emissions. So a good chunk of that is electricity production. for which we have a path, which is solar photovoltaic and wind and all those renewable sources. But there is also a heat part of this, and also part of this industrial process, for which we don't seem to have a path yet. Let's say we end up completely, going renewable on our power generation. All our cars are going to be electric, right? We really get on with net zero energy. Where will we get the heat or heating, steam that is required for our industrial processes? That is a big gap that we are not addressing today. And that is where some amount of attention is needed, because at some point we are going to run out of fossil fuel. Let's say in 50 years, 60 years. Then how will the industry run? Either everything has to be converted to an electrical equipment, but certain furnaces you can't convert to electricity. So either ways, this is a gap that seems to be falling through the crack, where the heat part of it, what is the path to renewables or reducing the CO2 or GHG emissions? That part is not something people are aware. And that's what I'm going to talk about a little bit, as to what are all the options we have, what has been done so far, still in infancy since last decade, I would say, maybe a little more, trying to gain foothold. So before that, a little bit of background to show why is it important in terms of, if you compare solar photovoltaic to solar thermal, now there are products which include solar thermal and solar photovoltaic in the market. This is at a different inclination, forget that. But what needs to be observed here is the amount of energy that is generated by photovoltaic. This is of course electrical energy, higher grade of energy, is 139 kilowatt hour per square meter, right? And when you compare the same thing, right, in this is in megajoules per square meter. I can quickly convert that to kWh if needed. But even the carbon savings you can see is much more. So as a path to carbon neutrality, solar thermal offers way higher benefits than photovoltaic. And if you can combine photovoltaic as well as thermal, then the carbon savings, CO2 equivalent savings, are even higher, and you get both output. So this is the reason why we need to refocus on looking at solar thermal to provide mostly the industrial heating, but in some cases, say in cold climates, even for buildings. It can also be used for commercial cooling. So there are two ways to do it. One is adsorption chiller. Breyer manufactures that. And then there is absorption chiller. Adsorption chiller can operate even at lower temperatures, say 60 degrees, 65 degrees centigrade. So therefore is more suitable to run on solar. You can see the solar field in the background here. So this is an installation we've done in South, in Tamil Nadu in India. And absorption chiller, of course, manufactured by Thermax and Kirloskar, even Voltas, I think. The challenge here is you require 85 degrees centigrade or above temperature, supply temperature. 90 would be better, right? So anything below that, the system will not operate. That is the challenge, and getting consistently that temperature is a challenge. Okay. So depending on the location and how you want to operate, the choice of the system has to be made. So why is that these systems are not being adopted? In various projects that we have evaluated, the paybacks are coming to somewhere around 6 years to 7 years. And that is where the challenge is. It is the cost constraint today that is stopping the adoption of this. And hopefully either the cost comes down or there are regulations or compliance to concepts like net zero or VCBC that will push adoption of these technologies for cooling. This is a typical schematic as to how one would install this, because the output from the absorption chiller is variable. It is dependent on the input from the sun, and input from the sun is variable, so you will get a variable output. So typically we install this on the return line where we take 12 degrees centigrade, and depending on what capacity is being delivered at that time during that day, this water will be cooled. Here I'm showing 9.55 and rest of it will go back to the chiller, the electric chiller that is there, right? Now, the reason why such a configuration is needed is there is a definite possibility that this will not deliver any output on a day, on a few days or something. When it's a completely rainy day, there is no solar radiation, the output by this would be completely zero. Then you need to derive all the cooling from the electric chiller. So this has to be kept in mind while designing solar-based cooling systems. Unlike our electric chillers, where we can basically determine what output we want, we cannot determine in solar-based cooling as to what output we want. We have to take the output that we get and modulate the remaining system as per that. So basically you get whatever free cooling that you get here, and then rest of it you use the electrical chiller. The most important application is in industrial heating, as I was saying earlier. Now, the trouble with industrial heating, I told that this is a large part of the GHG emissions. Now, the trouble with this is this is an example of different processes involved in a sugar industry. So you can see that each process has a different temperature requirement, right? Supply as well as return temperature. Now, when you have something like this, then the technologies that are required are different. The technology that is required to deliver 80 degrees water is different from technology that is required to deliver 130 and 360 or 200. So unlike other equipment, whether you're talking about solar photovoltaic or even chillers, they're more straightforward. It doesn't get as complicated. So let me show what I mean. This is the most common solar concentrator that many of you would have seen. This is a parabolic trough. These have been around since 1970s. Design hasn't changed a bit. But the challenge with this is that this requires very good radiation. I'll come to that in a minute. But this can deliver up to 350 degrees centigrade. Now, we have to be careful I have to be careful when I say 350 degrees centigrade. Now, it is capable of generating 350 degrees centigrade, but not everywhere. I cannot generate 350 degrees centigrade in Bangalore, in Delhi, or even Ahmedabad. This is capable of generating 350 degrees centigrade in places where the radiation is really high, maybe like place like Barmer in Rajasthan or Kutch in Gujarat. So we have to be very careful and understand the microclimate that is there before we select something. Just because somebody equipment is rated for that doesn't mean it will deliver that. A simpler solution, which is what found most amount of adoption in the industry, and this can be a beginning for all the industries, is a compound parabolic collector. This is a much simpler one, does not take ground space, can be installed on rooftop. This looks like your domestic hot water system. There is a slight difference. It's a heat pipe based one. You have a U pipe based one, where even if the tube breaks, it doesn't, the water doesn't leak. Okay. And this can deliver under pressure, 3-4 bar pressure, water up to 120 degrees centigrade. Again, when I say up to, it means that is the peak. On an average, you may get around 80 degrees, 85 degrees, depending, and it also depends a lot on the weather. Let me come to that as to how much importance weather plays. So this is the data for Bangalore. I've shown data for May, December, and July. You will observe there are 3 types of irradiance that are shown. One is global, other is direct and diffuse. Global is roughly the sum of direct and diffuse. Now, why is this important? Collectors, concentrators like this, they have a fixed focal point and they can focus radiation which is falling at 90 degrees to them. Only if it falls normal to it, then it will focus. Otherwise, it cannot. If it is coming at any other angle, that radiation is useless. So let's see what happens. So only this part of the radiation, the brown part of it, light brown part of it, is what is useful when you're trying to use parabolic trough. Whereas for compound parabolic collector, it does not matter. It can use this as well as this. So the input itself is much higher for a CPC, but it can deliver only hot water. So we have to make a choice. Do we go for steam generation with a lower input? Here itself, the system efficiency is compromised, right? Or do I go with hot water system, higher temperature hot water system, delivering overall higher kWh or megajoules of energy, and of course reduction of CO2. So you will observe that even in December, the radiation is pretty good. So it's not that it will not work in winter. It will work in winter too, and very well. Because if you see the radiation, the winter radiation is slightly better. Okay. But the duration, if you notice the duration of the radiation is much lesser. You will see that it is starting at 1 hour after the sunrise. Here it starts much earlier, GHI, and goes beyond 12 hours. Okay. But what happens in July when it is monsoon? What you observe is in monsoon, the direct radiation, which is required to operate this, is even lower than diffuse. So for 3 months in a year, a system like this in India will not work. So that also has to be taken into account in your payback calculations. Okay. So similarly, if you see the data for Delhi, you will see that May is a good time, a long duration of radiation, good. December is also good. However, see, all this is where I want to point out a little. Relying too much on satellite data. The reason is we don't have microclimatic data for a lot of places. So what happens, there's a project in Patparganj, right? Now, the problem there is there's so much pollution there that the radiation that is coming, even the beam radiation that is coming, collides with the aerosols in the air. It could be dust, water vapor, whatever it is, and diverts. So on the ground, when you see, it will be even lower than this. So anybody going for solar thermal should actually do a test of that microclimate in terms of the actual radiations available. And the reason why I'm saying this is even large companies, the companies which have put 50 megawatt of solar thermal, and even Reliance, which had put 2.5 megawatt, had made this mistake where everything was designed on satellite data, and the ground data was not taken. So when the system was started, they realized that there is a lot of dust, because of which the radiation which it is showing here is not that is something they're getting on the ground. So have to be really clear, especially when you're going with high temperature applications. In case you're not, if you're going with these, all fine. Even in rainy season, you will get some output. It will not be an entirely waste. Okay. So, sorry, let me skip. So there's another technology. I am using this to segue into another topic, which is Heliostat. We manufacture these so far for mostly R&D purposes. And the R&D purpose, these were manufactured because these can produce more than 1,000 degrees centigrade. Now, why is that needed? We have not found any viable industrial application yet, but these were developed to produce hydrogen by splitting, thermochemical splitting of water using a catalyst like zinc. So for which high temperature is needed. If you see here, I'll talk about the first step. What happens is you pass superheated steam at, let's say, about 500, 550 degrees centigrade over zinc, and that releases oxygen, but you get zinc oxide. Now, this zinc oxide is to be recycled because you cannot go on producing zinc oxide. Now, to break this zinc oxide is where a significant amount of energy is needed. If you compare here the amount of energy that is required and the temperatures. So this is where a lot of research is going on by different entities across Europe, in India, where ISRO and BARC are working on this to crack this. If they can crack this somehow to operate at lower temperature, then we have a fuel that will lead us to a path away from carbon completely. Okay. So this is the challenge that many research labs today are trying to solve. Let's see where they get. Last I heard, one research lab had gotten this down from 2000 Kelvin, which is about 1800 odd degrees centigrade, to about 350 degrees centigrade. So let's hope. But why is this important? Why is hydrogen important? I firmly believe that is our path. Remember, I asked you what will happen if we run out of fossil fuel, and then what do we burn for, especially our industrial process. So first of all, it's non-polluting completely. You have H2 plus O2, what you get is water and energy. There's no carbon involved in the entire process. And so what is happening is the water you used initially to produce hydrogen, you're getting it back again. Okay. And it can be produced from different sources, solar photovoltaic, you can use methane, you can also do from biomass. Indian Institute of Chemical Technology has come up with a technology where they're using biomass for generation of hydrogen. You can use coal or lignite also. One of the companies in South Africa, they are the largest producer of syngas, which is CO plus H2. And so from there, it's an easier path to get H2 and reform CO again for some use. Good thing, it can be used, stored for years. It doesn't deteriorate. Safe as LPG or petrol. I'll tell you why. I'll show you. It's an excellent energy carrier because energy density is quite high, 33 megajoule per kg. And it gives India energy security. If we can start producing hydrogen, we can produce it on our own. I mean, we have the best solar resource, and if we can use solar to produce our own fuel, that can be used for anything. And then it gives free oxygen. Now, why is that important? I'll talk about that in a case study that I'm going to talk about. So what can it be used for? We can use it for electricity storage. Now, it need not be, what you see here in the middle is hydrogen tank. You may think it is gas, but it need not be stored as gas. It can be stored as metal hydride, which is like a powder. It can be used for electricity generation through fuel cells. That is how, I'm sure most of you are probably aware that Hyundai's hydrogen fuel cell car just cleared the safety regulations, and hopefully they'll launch, but frighteningly expensive at this point. I hope more companies launch that here. And you can also use it as cooking fuel. Hydrogen can be used for cooking, just as you're using LPG. It can be used for space heating, automotive application. It can even be used for producing ammonia, which will go to produce fertilizers. So there are multiple uses. So that is why it makes sense to look at hydrogen also as a path, as a long-term path for us to achieve complete carbon neutrality in this entire image. You do not see any carbon anywhere. There is no scope for any carbon, and all you get is water, right? So some people may have concerns that is hydrogen safe? I mean, what if it explodes? Now, what we need to understand is the vapor density. Why does a gas cylinder explode? You know, we have a mixture of propane and butane, I think. So if you see the vapor density of it, when it leaks, the weight of propane is higher than the air. So it will remain there. It will remain close to the floor, right? And keep accumulating. And the moment there is a spark, boom, there is an explosion. But if it is hydrogen that is leaking, it will not stay. It will just escape from even the minutest space leak that it will get. So it will never accumulate. So the risk of explosion in hydrogen is far significantly lower than what we experience with the LPG that we use. And if you observe, even the auto ignition temperature is fairly high, right, compared to propane. So in that sense, it's safe. Having said that, of course, it's a flammable fluid. You have to take the required precautions. Right. So how popular is this? So you can see that world over, Europe is the leader, clearly. What I'm showing there is hydrogen fuel stations only as of now. That is not where all hydrogen is being used for different applications. This is only for automotive application. So you will see that most of it is in Europe today. good amount in Japan and some in China. There is, I think, there's one flag that you can see in India, but actually those are two. One is in IOCL Faridabad. They use their buses that run on hydrogen. And then there are 2 or 3 vehicles at National Institute of Solar Energy that were converted, not using fuel cell, but using in IC engine, where just like your CNG engine, the regular engine is used in hydrogen as well. So we are far away compared to others, and the costs are coming down significantly, and we need to look at this as an option for carbon neutrality because of the options it provides. I mean, the various usage option it provides. So most car manufacturers today have production versions of their cars already, fuel cells. So electric vehicles are now coming out in 2 versions. One is BEV, which is battery electric vehicle, where you have to lug around a lot of batteries along with you, which reduces the range. Other is FCV, which is fuel cell vehicle, which does not need to carry battery because hydrogen instantly will combine with oxygen and produce electricity and water. And that electricity will drive an electric motor. So that is one option, even though earlier attempts have been to use hydrogen as a gas, just like a CNG engine. But I think the world is moving towards using electric motor driven by fuel cell. So it's already there. India will soon have a launch of hydrogen car. The extent to which people are now considering this is, if you see, Australia has large reserves of coal, right? And that is one of the reasons why what Dr. Varun Jain had shown, Australia is one of the largest per capita CO2 emitter, right? It doesn't have any industry, but it's mining industry that is causing this. So what they are doing now, because they know very well the days of surviving on selling coal are numbered. So they convert coal to syngas and then to hydrogen and ship it to Japan. And you have to understand the geopolitics of this also. If you see the battery vehicle technology, Chinese have taken the lead. They own lithium. They have good domestic market for electric vehicles. So where does that leave all these European and Japanese auto majors? They are Toyotas, Hondas, Volkswagens, and even Korea, Hyundai. They can't be seen lagging. So they are leapfrogging to a hydrogen-based fuel where China has not yet got. Okay, these companies have made more progress on that than China. So that is why you will see Europe heavily investing in this. So how does it work? And there are different ways, as I said. Each one works differently. Solar thermal wave works differently from the one from methane or biofuel. What I'm explaining is the most simplest form of it, which has some commercial viability at this point, even though Elon Musk disagrees completely. And I'll tell you why that is a problem. Because they are looking at only automotive applications. In automotive applications, maybe yes, but there are many other applications. So what happens? You use electricity and you use water, and using that in an electrolyzer, you split it. This is like whatever 7th, 8th grade science experiment, electrolysis, right? And you will get um, oxygen and hydrogen. Hydrogen at anode, oxygen at cathode. And you capture both separately if you want. If you don't have any use for oxygen, you can vent it out, but you can store hydrogen. And whenever you need, you can put hydrogen into something called fuel cell, and that will again produce electricity and water. So you start with electricity and water, which is an endothermic reaction, which will take energy, right? It'll consume energy to split it. And then when you put it again in fuel cell, it's an exothermic reaction where it'll also produce heat actually. So we can use that heat if it is an industry or a place where heating is needed or hot water is needed. So this is how a simple fuel cell or hydrogen production using solar photovoltaic and fuel cell works. I'll just show a video of somebody I used to know long back when I was in US. He was the first one to install all this. People thought, I mean, even I thought he was crazy at that time. But I hope this will give a perspective instead of me going on talking, will give me some rest also.
Welcome to the nation's first solar hydrogen fuel cell powered home in North America. This home's been off grid now for 16 years, and we're using the power of the sun. I've had no electric bills, and I do cooking gas, heating gas, fuel for the vehicles, lawnmower, etc., all from solar hydrogen I make 3 months of the year.
So since this was installed way back, at that time, the metal hydride technology was not developed. So he had to go with tanks. But later in the video, you will see that he has moved to metal hydride and see the size of that.
There are two sources of energy that power this place. One is the solar energy, obviously, and the other one is geothermal. We grab from the ground. In 3 months, we make all the energy we need. So all the solar panels around here from April to about June goes into an electrolyzer that splits water into hydrogen and oxygen. That hydrogen and oxygen is then stored in these tanks forever. Whenever I need to use it, I pull off of the hydrogen, I run it through the fuel cell, I get the water back, the electricity, and then water goes back to start all over again to make more hydrogen. Solar energy's been around for quite some time. The biggest problem with solar energy is you can't store it. This system essentially bottles sunlight to use whenever you want, weeks, months, years, centuries from now. This is the only technology I've seen that can actually turn the ship around and go the other way and keep us from going off the precipice, or at least slow it down. You've just seen where we stored the hydrogen and where we generate the electricity from the solar panels. Now we're in my shop where all the magic happens. These are storage tanks, so
So this is the metal hydride storage that he has upgraded to now, where the storage size comes down quite a bit.
Storing the hydrogen in with something called nickel metal hydride. We've incorporated many new technologies in the hydrogen house that go along with conserving the planet. This hose is connected to an ozonator by my washing machine. I can get ozonated water out, and that super cleans clothes. It disinfects 300 times more powerful than bleach. Anything I can do with propane or natural gas, we're doing with hydrogen. Hydrogen is safe. It's safer than gasoline, diesel fuel, propane, natural gas, because it's lighter than air. Because there's no oxygen in the tank, it can't react without oxygen. So shooting bullets or putting fire, nothing's going to happen. Hydrogen won't ignite without having oxygen. This jewel box here does solar hydrogen. This is my hydrogen house in a box. You drop this on the top of a mountain, you drop it in the desert, it works. The equipment here has already been here for 16 years. My lawnmower runs on hydrogen, my motorcycle, my ATV. I have a hydrogen car here that I built in 2000, and the maintenance is very minimal. These are 2 hydrogen fuel cells. We took the show motor out of this Yamaha motor. We put in 2 hydrogen fuel cell stacks. This car has a 104 horsepower electric motor, which is out of a bus. So this car is enormously fast. So you're looking at the ability to outrun a Corvette in a quarter mile. cars that they're driving in California, the one I have here, the Toyota Mirai, every tank full in the Toyota Mirai is 12 gallons of water, drinkable water. We drove from Malibu to Vegas and back. And I stopped in Death Valley and I drank the water from the tailpipe. Car is super fast because it has no batteries in it. This is not the future. This is now.
So I hope that was useful. And just to show how the equipment has become standardized and modularized now. See, if you see these electrolyzers, they can now be stacked like, your computer racks, whatever capacity you want, just slap them there and keep increasing the capacity. Same with fuel cells. You have all kinds, but you can modularize the whole thing. And this is how your metal hydride looks. And again, these are also stackable and modularized, where you can keep increasing the storage as per your requirement. Okay, so this is how actually hydrogen gets absorbed into this and is stored there. And then when it is required, it is dissolved. That is how this works. Okay. And till yesterday, I was actually wondering, and many people, when they used to ask, I would say this is not viable in planes and all that. So that is why we've been pitching this, providing this solution mostly in Ladakh, where there are unique issues there, right? But I thought it's considering the current oxygen crisis, I put together a case study quickly to see how it can be viable, and any comments, criticism on that, we can take it up in the Q&A. So I had done a calculation for a simple 50-bed hospital, assuming that this small hospital is in some Jumrutalaya, some place, small place, where oxygen is never available anyway. Out of which, let's say 30 ports, out of 50 bed, 30 have oxygen ports where you require 3.5 liters per minute of oxygen. Normal flow rate is about, I think, 2 liters, but currently with COVID situation, you have to, I think, design for higher flow rate. So even if you assume 24 hours, 30 ports continuously consuming, you're talking about 144 cubic meter of oxygen requirement per day. Now, something like this, an online oxygen generator would cost you today 60 lakhs. And its connected load will be around 25 kilowatt. Okay. These are rough numbers, what I know. Now, instead of this, let's say if we were to use solar or grid electricity, let's say we use grid electricity itself, right? And we produce oxygen because that is the main requirement. We need 144 cubic meter per day. The advantage is this is not online. It can keep storing, so that on a particular day, only if 100 cubic meter is consumed, you still have storage available. But parallelly, at cathode, we produce hydrogen, which is free. Now let's look at the economics of this. Now, input energy that is required to produce this much of oxygen is about 1400 kilowatt hours, which at 8 rupees, it will cost about 11,200 rupees. Now, oxygen is what we want, so we get oxygen. Now, since we have saved that 25 kilowatt connected load of online oxygen generator, so I'm taking that into account. Let's say it was operating 24/7, so 4,800 rupees I saved there. But now I have hydrogen, which is free, right? Now, hydrogen, which is free, which I can use to produce electricity. I can produce about roughly a little over 400 kilowatt hours. So this is about 3,300 rupees. And the hospital requires hot water. So this will be roughly about 7,000 to 10,000 liters a day, which again would translate to about 3,200 rupees. So net, if you see, you're not, whatever input you have put in terms of money, you're getting it back. So zero operational cost, but what are the budgetary numbers? I can put that. The payback comes to roughly about 3 years or so. Okay. So I just wanted to show it. Just yesterday struck me with this oxygen shortage that we can keep doing this and get additional benefit instead of buying oxygen from industrial sources, especially for remote areas. Maybe we will get it in, I mean, I wouldn't say that. I was going to say maybe we will get it in places like Delhi, Hyderabad, but even that is not the case today. But this is a good application, I thought is very relevant, which originally I had made for a remote location in Ladakh, a frontline hospital actually. Yeah. So from such simple applications, you can get into very, very complicated systems also, where cement industry is trying to look to reduce its CO2 consumption. So the CO2 it emits, if it can use hydrogen, it can produce energy can be used. So you can get into where the entire energy that is coming out waste can be systematically used for various purposes. Yeah. So with that, I think I will stop. And I'll stop and maybe take questions, or you can tell me what is the plan.
Thank you, Madhusudanji, and it was really very interesting presentation. And the best part of it is that the byproduct of hydrogen solar thermal is O2, oxygen, and the entire country today is struggling to get oxygen for hospitals, and people are dying because of this. So wonderful presentation, and I will take the questions. People have put that on Q&A. I also have few questions. I will mix and match. So the first question is that do not we need a paradigm shift in the use of low grade of energy such as heat and chemical directly at the place and equipment where it is required, rather than producing electricity from various resources, then transmitting and distributing your take, please? So,
sorry.
yeah, please.
Yeah, I think I understand what the question is. Yes, it is right. One needs to understand that there are options other than electricity for renewables and biomass. These are the two default things that people go to. I would say a mapping of all the industrial processes which are low-hanging fruit can be done. It has been done. It's not that the effort has not been there. Effort has been there for MNRE, and then GIZ had done some study. There are, I would say, the implementation lacked commitment, because if you see something like solar PV, it had it was mandatory on discoms to have at least 2%, or large consumers to have at least a certain amount of electricity from renewable sources, even before it was viable. There has been no such market creation activity, because how else will you get the scale, the volume? So how much awareness you do, the cost becomes a bottleneck to begin with, and that is what is still a problem. Okay. And because of which, I think industry is aware, but there need to be a lot more players who need to see this as a viable business to jump into it. That is not there today, and that would require a big push from the government.
Okay. So the next question is that we see photovoltaic, we see solar thermal also, But you have mentioned in your presentation there is a hybrid system where we can generate hot water also, and we can generate electricity also. Now, but we don't see that installed at places. Why is there any limitation? Is the cost is the limitation? Is the payback period is the limitation?
So the challenge there is, it is suitable mostly, I would say, for hotels or hospitals. The reason is, when you are trying to get both, you cannot get high temperature water from it. Because if you try to increase the temperature of water that you're going to get it, you will increase the temperature of the solar PV field. So solar PV panel, which will reduce its performance. So somewhere there has to be that balance. And therefore, those do not provide, as far as I'm aware, beyond 40 to 45 degrees hot water, which is useful only for hotels and hospitals.
But are these being getting installed in hotels and hospitals? Because I have not heard much where the hybrid system is installed.
There's a company in Hyderabad called Bird's Eye. They are doing it.
I heard about them.
Yeah.
Okay, wonderful. The next question is that we can get from parabolic collector 350 degrees centigrade of hot water, and from CPC we can get up to 120 degrees centigrade of water. But when we make it hybrid, you said it is 45 degrees. So you have already answered that. Now another question is it feasible to run hybrid of absorption and adsorption chiller operating at different temperatures available?
Technically possible, but my guess is that it will be too much of an expense to incur. You might as well continue with adsorption chiller if you're going to get lower temperature water. That's my immediate reaction. It may not make sense in terms of economics.
Okay. Now, when we use absorption and adsorption, both are closed cycle, right? And we get hot water and we get chill water also. Now, in your graph, you had shown that we get good amount of solar energy during winter. So places where we have composite climate like Delhi, Lucknow, and other places, are we able to balance the demand and supply, or do we need to store the hot water or chill water, or what is better to store hot water or chill water?
Sir, Delhi mein aapko garam pani chahiye na?
Yeah, no, winter. That's what I'm saying. In winter,
you can use it as hot water itself.
Yeah. So what we are saying is that we can get temperature up to 120 degrees centigrade. So you are saying that you have used it and it can balance both the demand and supply.
No. Okay, let's go step by step. When I say up to 120 degrees centigrade, I am doubtful you will get that in Delhi in winter, because Delhi mein itna kohra hota hai. I mean, you know from using domestic solar water heaters itself what is the performance, right? That is why I said the microclimate is important, right? So realistically, I mean, looking at the satellite data, it looks feasible, but on the ground, you will not get it.
What is the temperature we can get in winter?
In winter, if it's a cold but clear sky day, you will get 80-90 degrees centigrade for sure. But if it's a cloudy day, at best you will get about 60 degrees centigrade.
Okay. One more question. When you said in a cloudy day we get 60 to 70 degree or 80 to 90 degree in winter, so open cycle like solid desiccant require very less temperatures, but we don't see much of solid desiccant or liquid desiccant used in air conditioning, because the amount of humidity control is very less as compared to humidity reduction is very less as compared to what is required in industry. But why don't we see the desiccant in the industry when we can get such a temperature from solar?
Yes, that is a possible solution. The only issue I have seen that is most have been experimental installations, and there are hardly any commercial products available.
So is it because of awareness or as a commercial project? So products are not available, you are saying?
There's one Australian company which had, then there was an Israeli company which had, but Beyond that, we have not seen them last long.
So the other question is, what are the available positive such as resources, technology, etc. in India in moving towards gas-based economy, particularly hydrogen?
I quite didn't understand the question. What was
What
the
are the
question?
available positive such as resources, technology, etc. in India in moving towards gas-based economy, particularly hydrogen?
Uh,
Do we see that in near future or?
yes, I definitely see that. One is, see, today the conversion efficiencies are max about 70%, or if you take electrical conversion efficiency, it is only 30%. Just last month, Bill Gates invested in an Israeli company that claims to deliver 98% efficiency. So 98% of energy it took, it will give it back, right? So when those technologies hit the market, which is in 2022, you will see a lot more adoption. Today, like with any technology, initial cost becomes the constraint. As the cost gets addressed, and as we keep finding new applications where it is more viable, right, we will see that the market will take off.
And this will reduce greenhouse gases also.
Yes,
So
definitely.
another question is blue hydrogen versus green hydrogen.
Yeah, so there will always be space for blue hydrogen. There's no doubt. What do you think Coal India will do, or Mahanadi coal fields will do, right? All these companies have to figure out their survival. And if nobody is going to buy coal, I mean, technically we are supposed to get out of, according to Paris Agreement, by 2040, we are supposed to get out of coal-based generation, right? So it is a big question mark in terms of what is the future of coal. So everybody from starting from NTPC to hopefully Coal India, or there is a project under Ministry of Mines that we were involved in. Everybody is looking at multiple options, and one of this is how do you convert uh, coal or lignite into hydrogen, either in terms of methanol. It can be a liquid fluid. It need not always be sold as hydrogen. It can be converted to methanol. It can be ammonia, any value-added product that it can do. And how does that happen? See, syngas is more than a century-old technology, right? That is how England used to power. Used to have gas in London, and maybe for some time even in Bombay. So if we can, and that's technology is something that is perfected. So from syngas, the next step is to figure out how to produce or extract hydrogen, and again reuse the carbon that is produced in the entire process. So I think there is enough research going on, and that will also have a definite space, because country like Australia, that is what they're trying to do. They're selling blue hydrogen. Ultimately, we have to go towards green hydrogen, but until then, blue hydrogen will also definitely have space there.
How many countries are we producing hydrogen through solar?
There are many. Europe has many projects now. There's actually even a 6 gigawatt or 6 megawatt power plant which went in production in 2019 in Europe. So there are, you name any country today, Germany, Sweden, Denmark, UK, every country, even Thailand. I was there a couple of years ago. Even Thailand has a house that is completely driven by hydrogen.
Wonderful.
Sure, China has, Japan has. But that gives you an idea of where the other countries have progressed. Whereas we don't have anything except the one at IOC and National Institute of Solar Energy.
So how far we are from generating this hydrogen from solar, or using hydrogen as a fuel?
I mean, technology is there. We're just waiting for a few projects in Ladakh where we find. So the cases that we are working on is the frontier hospitals. They struggle really to get oxygen.
Oh, okay.
And they have requirement of, see, Ladakh is uniquely placed. They are off grid. They need electricity. They need oxygen. They need heat at any point of the year.
You're right.
Right? And if you see, their solar radiation is completely out of sync with the rest of the country, or the energy need. Their energy need is in December, January night, when there is no solar radiation. Even solar radiation in winter is so low there. Whereas in summer, the solar radiation there is around 7.1 kilowatt hours per square meter, whereas winter it is less than half of that, below 3. Whereas in summer, they don't even need fan, right? They don't even need fan. So what are they going to do with all this energy? And there is no other technology today that can do seasonal storage. If you want to use today's electricity in the night or tomorrow or a day after, okay, batteries. But if you want to use maize energy in December, there's no other option, right? So the economics there are a little different. Therefore, we are pushing for some projects there. Let's see, hopefully this year.
The other question from our participant is that what is the purity level of oxygen which can be achieved?
99.99.
Wonderful.
Normally, the hospital oxygen is between 94 to 95.
So the other question is, do we have any such oxygen generation system installed and operational in India?
No, I mean, this application has not been installed anywhere in the world. Everybody is after, see, who's putting money into this? Toyota, Hyundai, BMW. They are putting money in applications that they will derive money from, right? But these applications, people like us who design systems, right, have to come up with and design and implement. Otherwise, it is not a standard product. Ki hydrogen car hai, Toyota Mirai kharid lo, right? This is a significant amount of application design that is involved. You have to integrate with hot water system, you have to integrate with electrical system. So if it were some out of the box solution, maybe it would have been installed, but as of now, it is not there. I'm not aware of being installed anywhere.
So the other question is, what is the initial cost of refrigeration system, vapor absorption machine, operated using parabolic concentrator compared to steam operated VAM? What about operating cost for both the systems? Is there any comparative which might have been done like this?
So roughly, an absorption chiller, hot water absorption chiller will cost you roughly anywhere between 35 to maybe 40,000 rupees per ton, depending on what size you are going. To which you have to add the solar field size. Rough rule of thumb again is 10 square meters will deliver roughly 1 ton of cooling. And each square meter would cost you anything, depending on the size, again, anywhere from 10,000 to 15,000. So even on the lower side, you're talking about 1 lakh rupees plus 35,000. So that is just for the solar field, and so a rough cost would be around 1.5 lakh per ton. There will be some economies of scale when you go for a bigger system. Adsorption will cost a little bit more, maybe 1.8, because the cost is higher, but you get more cooling output, more number of hours of cooling output. So you have to also look at it in terms of compare not just tonnage to tonnage, but TRH delivered to TRH delivered. So which requires a little more analysis as to what is the TRH you will get, because that is what the energy saved is.
For this. Okay. So the other question is there any authority which is providing microclimatic data required to go forward for design?
Not really. I mean, nobody can provide microclimatic data. The best you have is IMD had in last 4-5 years installed a lot of temperature weather stations. So you can get from that. But I'll give you an example as to, let me just share the screen to make it very clear as to, so I'll just show you. This is one of our sites where we have installed radiant heating with solar thermal, with solar PV and geothermal, everything. Now, when we do the heat load for this, we would do the normal heat load, and we would calculate what is the convective losses instead of transmission losses, because this is heating system, heating project, right? Instead of transmission gains. Now, the problem here is that when you calculate, normally we do not take care of any convective losses, additional convective losses that will be there, right? Now, what happens here is this is in between valley. This is right of this is Pangong Lake, and left is actually a valley opening up to this. So huge amount of wind comes here, hits the walls, hits the mountain on the opposite side, and then again comes back. So there's so much convection happening, and the temperature of this air is usually many times in winter less than -20, goes to -35, -40. Now, unless we understand this microclimate, that this air is there, we wouldn't take care of the additional convective losses that we should expect from the building because of this high velocity of the wind that is going to keep hitting this building. So no amount of data, and we had advised the paramilitary force to put these weather stations at each of their locations where they're planning such a thing. So it changes, microclimate changes every few hundred meters, that it is from the site you have to get it. There's no other way. I hope I made that clear.
Is there any way to, or any tool is available to do CFD analysis and try to find out what is the convective losses, or there's nothing at present?
Well, tools are available, but it all depends on what assumptions you take in that, right? In the same example, if in your CFD analysis, you have not taken the external convective load, then the analysis will also not be correct, right?
Yeah.
It's only a tool.
So our last question is, please throw some light on role of carbon capture storage in reducing greenhouse gases.
So there are various technologies that are being tried, because somewhere around 2015, I think Ministry of Environment had given a notification for all power plants to reduce their CO2 emissions per kilowatt. They are supposed to bring it down to 3.5 per kilowatt hour or something like that. And even SOx and NOx, SOx and NOx. This was not there earlier. Earlier, all you had to do was if you're constructing a 500 megawatt power plant, all you had to do is construct a chimney so high, roughly about 273 meters, so that you can disperse. Like they say, dispersion is the answer to the pollution, right? If you disperse enough, there won't be enough pollution. But all that changed. But the technologies, there are a few technologies, but except for NTPC implementing it in 2 of their plants. There has been no further installations of this technology as far as I know. The problem there is this: any of the current technologies which are there will add at least about 35 to 50 paise per kilowatt hour to the generator. Now, it's a contractual issue there. Now, whichever authority which has signed PPA, let's say Delhi Rajdhani Power or somebody who has signed it. Now, if they have signed the PPA at 3.5 rupees for 25 years or whatever number of, okay, and why would they break their contract to increase, to give 50 paise extra to NTPC? They're not. Neither is the government passing that load onto the consumer. So this is where it is stuck. Who will bear that cost additional? Because you have to put for NOx control, SOx control, mercury, CO2, all this. So the technologies exist. There are multiple carbon sequestration technologies that exist. There are algae-based ones which are there. They are most common ones are where you use gypsum slurry, lime slurry to reduce it to calcium carbonate. But then problem is, what do you do with the calcium carbonate, right? It depends on some place. Calcium carbonate may be of value in Manipur, where the cost is higher because I can make gypsum, may not be of any value in Tamil Nadu. So those are all technical challenges, but the biggest issue is who will foot the bill. That is where it is stuck.
Wonderful. Thank you, Madhusudanji, for delivering this wonderful session and telling our participant and us the path to carbon neutrality using solar thermal solutions. And it was a wonderful presentation also. And because of the questions, interesting question asked by our participant, it has given a good insight. I would request the participant, if they have questions, they can write to DCI and we can take those answers from Madhusudanji later. And during COVID also, he was here and patiently he was delivering. Thanks to him a lot. Thank you, Madhusudanji.
Thank you. Thank you again.
Thank you, Varun Ji, and thank you, Madhusudanji, for this wonderful session so far. I mean, like, it was really amazing. And thanks, Madhusudanji, for, despite your current state of health, you've been very patient. And I think the all DCI and the all ISHRE members will really benefit from what the information you've shared. I think it's just the starting of a discussion. It's probably not the end of it, but I think it's a good point to start. So in the next phase of the today's program, we have a small group discussion where we have 4 panelists with us. And before I introduce the panelists, we have like 4 slides from one of our sponsors. And I would request our secretariat team to just run these slides till we queue the rest of the things together.
Thank you, sir. So LP Aeroflex is our gold partner for DCI. They provide insulation solution. These are some details of LP Aeroflex. Key certification, key projects. This is the contact number of LP Aeroflex. You can contact him directly. Thank you.
Thank you, Tapas. That was short and sweet. And thank you, ALP Aeroflex, for being our partner. Now, I would request, we have 4 panelists today, and I would request you to, if you can switch on your screens. Mr. Dinkar, can you, Dinkar Saxena ji?
Yeah, sure.
I would like to see all. Yeah, and then Glory ji, Rajesh Vig ji, yeah, and Satish ji. Can I see you all? All are here now. Tapas, can you see everybody on the screen?
Yes, sir.
Great.
Mr. Satish
So
in
it is.
will ask them.
So it's an honor to introduce our panelists today. So Mr. Dinkar Saxena is an empaneled consultant at Regional Center for Urban and Environmental Studies. He has an independent consultancy services for water treatment, pollution control, and chemical process controls. He's a chartered engineer, member of IEI India, ASHRAE, ISHE, and fellow of IPHE India. He has specialization and interest in the field of water, wastewater treatment, low-cost sanitization, sustainable wastewater treatment systems, and multi-stage cascading of membrane. So welcome, Mr. Dinkar Saxena. And he's also the president for Agra subchapter. Then we have Glory ma'am. Glory ma'am is the president for Lucknow subchapter, and she has 17 years of experience in architecture, interior, residential, and commercial sectors. She is a principal architect and founder of Build Green Design. She is an ECBC expert and works on ECBC compliance. She works on N certification of green buildings, training, awareness, and save for government officials, industry professionals, etc. And she's a BIM expert. Satish Kumarji is CEO of Shubh Aircon. He's a mechanical engineer with 14 years of experience in HVAC project design and execution. Mr. Rajesh Fik is a mechanical marine engineer with 38 years of experience on various projects, including merchant vessels, reefer ships, hospitality industry, both nationally and internationally. And he is at the moment the president-elect for ISHRAE Merit subchapter. So welcome you all. So I think I assume that you have all been a part of the program so far. And so I'm talking on the green, the Earth Day today. One question that I would like to put to all the distinguished panelists is that it is a fair assumption that no country has managed to lift itself out of poverty without a surge in climatic emissions. So China's, if you take a case of China, the spectacular economic rise led to an explosive jump in its carbon emissions. Where do you, say India stands on curbing poverty and the carbon emission? I hope my question is clear. It's a little longer, but I hope it's clear to you. And anybody, maybe I can start with Mr. Dinkar Saxena, if you can, answer this question.
India stands, Namaskar. India stands on a, we have to go for carbon emission. It's not carbon emission, carbon utilization, but gas emission would be there. But we need to have, as the presentation थोड़ी देर पहले Madhusudan साहब ने दिया, there's a lot of clues are available where we can reduce our greenhouse emission lesser. Like in Leh also, I have designed one of the STP for one of the military installation. There I use the power from the solar, and it's for heating as far as decomposition of the waste as well. Right, and there's energy available also. So carbon utilization या आप गैस total gas emission को करना है, हमारी economy को सही करना है. So we have to go for the China way. Only thing is that we have to go side by side to control the gas emission. Means एक और मैं example देता हूँ. There's a Jaipur dairy is there. Jaipur में there was a lot of sludge is coming out. What we did, अगर हम ऐसे खुले में छोड़ देते हैं, तो that petrified होके methane gas generate कर रही थी, and it was giving a lot of bad smell and all other problems, including greenhouse gases. Now what we did, we generate a reactor and उससे हमने methane gas को collect किया, and we are getting a methane up to purity of more than 82%, and that is being used for the firing of the boiler. So you are आपका energy को हमने use तो किया, but net carbon is reduced. Carbon footprint, I'll put it the right word. Carbon footprint is reduced by using various technology. तो मैं ये कह नहीं सकता कि हिंदुस्तान में ऐसा नहीं हो सकता. Like Chinese, they have done it. They have cut the gas emission as well. And अभी हम लोगों का जो total consumption है, पर अगर माने तो we are below, way below from the worldwide. हमारा 0.56 टन पर पर्सन का जो हमारा कंजम्पशन है पर ईयर का वो है हमारे टोटल पॉपुलेशन को देखते हुए. Whereas American is using 10 tons. This is almost 20 times to us. And that is the reason they are having a higher economic rate. तो हमें economic rates में आगे आना है और करना है simultaneously. I'll say that we need to go for innovation like Madhusudanji Sahab has done, and the way other industries are also doing.
Thank you, sir.
So I think that is the right answer.
Yeah, I think we get here. What you're saying is that obviously there is no second thoughts that we do need economic development and it's full swing and the full power ahead. But at the same time, we have to learn not to do what others have done, and at the same time, we need to adopt more newer technologies. Part of which probably something we'll discuss today, and there are other things that you've also discussed and brought on the platform. I would request Glory to have her view on this. I cannot see Glory on the screen, but Glory, can you hear me? Please.
Am I audible?
Yeah, wonderfully audible. Thank you, Glory.
Yeah. You can see
we can
me
see
also,
you. Yes, we can see you.
A very good evening, all of you. A very happy Earth Day to all the members, all the viewers out there. Yes, as far as the carbon emission is concerned, India is, because of its industrial growth, we see a lot less as compared to other countries. But yes, India also needs to, once there is industrialization in all the phases, it's like 90% of India is under the villages, more than 90% in fact. That's why we see this kind of graph. But the decline in the economic growth and the rise in the poverty, it can be minimized if the emission restrictions, all the restrictions that and the target what we need is modest. And moreover, if the carbon tax revenues are also transferred exclusively to the poor, and if India's participation in the international trade emission permits the regime regarding the emission allocation, it's preferred, then even the domestic carbon tax option can be opted for. Even that is one of the options. We could have even better India if India could participate in the global system of the tradable emission permits, which is equal to the per capita emission entitlements. India then would be able to use the revenues which can be garnered for the economic growth as well. So this is also one of the ways where tradable part of the carbon emission can be taken care of. Apart from, yes, technology does play a very important role.
Yeah, that's a great idea, Glory. And I think in the whole technical jargon today that we've been talking, we forget that nothing beats motivation than money. So it's a great idea. Yeah. So quickly, Rajesh ji, can you add something to this? I think Rajesh ji,
आपकी आवाज नहीं आ रही है.
राजेश जी, आई थिंक आपने अपने आप को म्यूट कर रखा है. आप अनम्यूट करेंगे अपने आप को प्लीज? या आई थिंक यू आर अनम्यूटेड. यस प्लीज. We can't hear you. Anyways, till we get Rajesh ji back online, Satish ji, would you like to comment something on this point?
सर, कार्बन पॉइंट को कम करने के लिए हमें जितनी भी इंडस्ट्री हम डेवलप कर रहे हैं, पिछले कुछ दिनों में डेवलप हो रही है, हमें सिर्फ यही देखना चाहिए कि जितने भी हमारे इक्विपमेंट हम यूज कर रहे हैं वो लेटेस्ट टेक्नोलॉजी के हैं और कार्बन पार्टिकल्स कम से कम जनरेट हो और हम तेजी से आगे बढ़ते रहें. और कार्बन पार्टिकल कम करने के साथ लेटेस्ट टेक्नोलॉजी के साथ ही हमें आगे बढ़ना होगा. उसी चीज के साथ हम आगे चल सकते हैं.
ठीक है, थैंक यू सो मच. दिस नेक्स्ट क्वेश्चन probably is to Dinkar ji, specific to you. Is it possible to achieve the targets of Paris Agreement without private sector joining hands with the government? अभी हमने पिछले वरुण जी की presentation में देखा था, the targets we have accepted, whether voluntary or involuntary. So सवाल के दो पहलू हैं कि क्या हम उसे अचीव कर सकते हैं, A, और दूसरा क्या इसमें गवर्नमेंट एंड प्राइवेट सेक्टर की दोनों के मिलना होएगा तभी होगा या इंडिविजुअली दे कैन अचीव?
Yeah, definitely. We can achieve. I'm always a hopeful person. Or we can achieve, but definitely, since major, I tell you, industry consume almost around 23% of greenhouse emission, right? Transportation use 29%, right? Electricity generation, it takes 25% of the total expenditure. Agriculture and commercial takes both inclusive 23, right? Because agriculture, when you grow it, it also deposits the carbon, right? So it net effect is quite low. As similarly for the household, consumption is also not very high. Only issue, if you leave alone the industry or if you leave alone the transportation, which is mostly done by the individuals or public participation, right? You cannot achieve the target at any cost. So a public government participation is essential because major जो आज भी देश में जो सबसे बड़े हमारे उद्योग हैं, चाहे वो स्टील हो या मेजर कंजम्पशन वहां से जनरेट हो रहा है, एंड वी नीड टू कर्व दैट. एंड अदर सेकंड थिंग, जो आपने पब्लिक के लिए बोला, मैंने पब्लिक पार्टिसिपेशन इसलिए बोल रहा हूँ, मैक्सिमम ऑफ ऑल जो मैंने अभी डिस्कस किए उसमें 29%, दैट मीन्स दैट इज द मेजर पार्ट, ट्रांसपोर्ट, कार्स, ट्रक्स, बस, रोडवेज and aircraft or marine, they produce the maximum of the possible green, and that is creating offset for the government. Government cannot control that. जैसे ही अभी उन्होंने बोला कि हाइड्रोजन सेल्स लीजिए, yes, say for electrical vehicles, right? Electrical vehicles again will drive energy from somewhere. That means the demand of electricity will increase in the production sector, right? Again, that will create a greenhouse emission. Unless that power which you require to drive your electrical vehicle is taken from the solar or for wind or some kind of other regenerative methods, definitely you will participate. But for that, you require public participation.
थैंक यू. मैं आपकी बात से ना सर एक और सवाल, मतलब मैं इसी बात के रिप्लाई से एक और, आई थिंक आई विल आस्क दिस टू राजेश जी, अगर आप अनम्यूट कर सकें. सी अभी जैसे दिनकर सर ने बात करी, एंड वी टॉक्ड अबाउट पब्लिक एंड गवर्नमेंट पार्टिसिपेशन एंड देन वी टॉक ऑफ इलेक्ट्रिक व्हीकल्स. सो मेरा सवाल ये है कि वी सी लॉन्चेस ऑफ इलेक्ट्रिक व्हीकल्स एवरी ईयर, but we are not seeing considerable numbers of electric vehicles on the roads. I mean, like, what would be the challenge? So hypothetically हमने सारी चीजें अच्छी बात कर ली, but nothing is transpiring which is visible and visual. तो आपको क्या लगता है सर कि क्या challenges हैं where when we're talking of this concept of public partnership, and as we are all aware of green, we can't hear you, sir. Can you speak again, sir? You're muted, sir. Raj.
आपको एक बार अपना सिस्टम रिबूट कर लीजिए, सही हो जाएगा.
हाँ राजेश जी, आप ना लॉग इन दोबारा कर लीजिए एंड यूज कंप्यूटर ऑडियो. सो आप एक बार लॉग आउट करके कर लीजिए. I think Glory, maybe I'll put this question to you. Why don't we see tangible results on the road? I mean, what are the challenges?
Yeah, in terms of challenges, I would say that right now the infrastructure is not that developed, first of all, for the electrical vehicles. The infrastructure that which we need the charging points, we need the exact at the particular distance we need all those charging points. Right now we are not ready, the market is not ready, the infrastructure, you know, that is not ready for this type of huge transition. Hybrid is still possible right now, but yes, right now what we see is that in terms of the infrastructure wise, yes, it is definitely lacking, and that is the main reason people are not really responding to it. Yes, in due course of time when it becomes mandatory, and since all the you know, all the certification bodies and everywhere we are getting it's become mandatory to have charging points, and at certain distances even two
I
or
will
three
just,
charging points.
ma'am, I will again put a same question in a different format to you.
Yeah.
The new cars that have probably been launched right now, they have the capability of going like 300 kilometers to one charge. Now, given a city like maybe Lucknow, maybe given even a city like Delhi, you know, maybe people don't drive over 200 kilometers. 200 kilometers per day is also a huge travel point, I'm saying. I agree, maybe you cannot go from Delhi to Lucknow, but if you're doing within Lucknow or if you're doing within Delhi, you have good 300 kilometers charge, but still it's
But
not
yes,
happening.
yeah, it's not
So maybe
happening
there's
because
more than the charge points. It maybe can you look
the
into
availability of the cars right now, the number of cars which are available, easily available, you know, the local cars which are available, they are not into the electrical mode right now. These are few of the reasons, I would say. And but slowly and steadily it is definitely picking up, and it will become a mandate very soon. But then again, the electricity itself will be is also a concern. Like for instance, even air conditioning, when it comes to air conditioning, it takes up huge cost. This again will take up as a huge cost. So electricity, maintaining that kind of electricity, as well as the number of cars, the plus the infrastructure, all these factors I think are responsible for the surge, and plus the awareness in the market.
thank you. I don't know if
Yeah.
Satish ji, can you say, you know, probably top 2 points that how we can make it more possible? I think Satish ji is logged out. No,
Hello.
Satish ji is here. Yeah, Satish ji, can you top 2 points that you would say that we can
सर
do
सबसे
to
पहले
make this?
इंफ्रास्ट्रक्चर उसका डेवलप होना चाहिए, और अभी लोगों को ना उसकी मेंटेनेंस कॉस्ट, उसकी रनिंग कॉस्ट किसी के बारे में भी पता नहीं है कुछ भी,
Idea.
इसलिए हम उसमें आगे नहीं बढ़ पा रहे हैं। अभी हम किसी से भी फील्ड में बात करते हैं, इलेक्ट्रिक व्हीकल मार्केट में है, तो उसके बारे में किसी को भी नॉलेज नहीं है। आई थिंक इंफ्रास्ट्रक्चर प्लस मार्केटिंग इज नॉट डेवलप्ड टिल नाउ। लोगों को पता होना चाहिए उसके बारे में, तभी वो आगे बढ़ेंगे। जो मिडिल क्लास के आदमी हैं, जो मेनली गाड़ी को लेकर चलते हैं, गाड़ी खरीदते हैं, हमारी इलेक्ट्रिकल व्हीकल जो होते हैं, उनको सारी नॉलेज अभी नहीं है और वो थोड़ा डरे हुए हैं। सबसे बड़ी बात है, कहीं भी इंफ्रास्ट्रक्चर है नहीं, चार्जिंग पॉइंट अभी कहीं डेवलप नहीं है।
Yeah, I think we agree to the point that infrastructure. So it's like chicken and an egg story, but I think here we need to have the eggs before the chicken come out. हाँ जी दिनकर जी प्लीज। हाँ जी
एक चीज मैं ऐड करना चाह रहा था ग्लोरी जी और सतीश बाबू के संदर्भ में, कि हमारे यहाँ जो इलेक्ट्रिकल व्हीकल है, till the hydrogen cell come, because then you can store the energy for a longer time. Even if you charge a system, and the capacity of the energy density would be much higher in the fuel cells, right? अभी वो possibility हमारे यहाँ है नहीं, और इसकी वजह से जो सेल बेस्ड या बैटरी बेस्ड जो सिस्टम है, जो चाइनीज बैटरीज हैं, लिथियम आयन या लिथियम जो भी उसके नए नए प्रारूप आ रहे हैं, उनमें भी हमारे पास इतनी एनर्जी डेंसिटी नहीं है कि वी कैन टेक द व्हीकल फॉर से 500 or 600 kilometers, because generally the people is not looking for the vehicle for the local transport due to the COVID and other thing. Generally they want to travel to one city to another city, so that is the distance which everybody is worried कहाँ कैसे भरेंगे। तो हाइड्रोजन फ्यूल सेल आ जाएंगे, then the things would be much better. That means what my thought is, with the design और जो हमारे equipment designer है, वो they need to go for energy storage and transport as well. Just like petrol, you can avail from anywhere and fill it and then move away. Fuel cell cannot run that fast, but definitely you can do something.
No, but I will just probably close this point here because मेरे को एक सारा quickly एक सवाल and anybody can answer. What Madhusudanji also said in his in his presentation. So there are technologies available. There are two things that he said: a, viability, I mean like payback period, and number two he said was who will foot the bill. Do you see any challenges on these two fronts with the let us continue the topic of electric cars itself, because I believe ki batteries will also have a life. The initial cost is also is a concern area. Then end of the day कितनी भी philanthropy हर एक इंसान के अंदर हो, लेकिन वो पहले कहता है कि my cost. One of the reasons for CNG to be successful was because the total cost came down by running. So it was not like people were all of a sudden very, very philanthropist कि नहीं जी कल से हम environment के लिए खड़े हो जाएंगे. There was more economic sense. So do you think economic sense is also very essential, despite the fact that whatever we may talk on the, being good about everything? So quickly, like 10 seconds probably each can answer on that.
Definitely.
Yes.
Energy cost and total equipment cost, ownership cost. If it is less, definitely the things are going to survive.
Yeah, Glory, anything from you?
Yes, exactly. This is a major point. CNG को adopt करने का reason कहीं पे भी ये नहीं था कि environment is the reason. The only cost, the first reason was कि उससे running cost was going down.
मेरा आज का काम जो है ना सिर्फ आपको सवाल से दूसरे सवाल में फंसाने का है, ठीक है? So and I think I'm not gonna make the panelists' job easy. So going from where we started a public-private partnership, then we went into electric cars, and we said that okay, philanthropy doesn't happen. My next question, and
I would like to add on the private sector thing.
Yeah, I will give you a chance. So let me complete my question because then मैं भूल जाऊंगा.
Okay.
So so we made again going back to where we started from the starting of the presentation, and then we said that in the Paris Protocol in agreement we made some commitments of creating a carbon sink by 2030, right? And that carbon sink has to be in the tune of like 2.5 to 3 billion tons of CO2 equivalent, right? That's a huge figure, and we are in 2021. We all know between all of us that there are very, very limited ways of creating a carbon sink. Now, have this to be happen, how do you propose that it could be done and achieved? Okay, anybody can answer that. Definitely. And probably I will open this to Mr. Varun also, Dr. Varun Jain also. I will open this to Dr. Varun Jain. So if, probably how do we know where we want to go. We know there are challenges, and we know the time is not something that we have as a luxury. How do we achieve it? Anybody can answer, please.
There is definitely no substitute for forest reserve that we have, definitely. And the way deforestation is happening, builders are taking up colonies, and the way massive cutting of trees is happening, we don't see it technically happening. But yes, there are lots of ways of getting into it technologically. The buildings that we design, the buildings that the builders are getting into, high-rise buildings where they can plant as many trees that are possible to cover that loss of the trees that they have already made. Moreover, there are lots of other ways in the sense while construction itself, by reducing the embodied energy, by using those materials, that low carbon materials in the building itself. Those carbon sink building materials can be used, which are harvested wood products. The wood that has been really harvested, which is not the natural wood, because wood that has been harvested can capture carbon again through the process of photosynthesis. Almost like 50% of the dry weight of the wood is carbon. And the amount of carbon is all in almost like 1 meter cube of wood is similar to that of almost like 350 liters of gasoline, as per the papers, So it is important to ensure that that wood which comes is from the sustainably managed plantations, it not from the carbon, not from the illegal forests, logging of the forests, not the carbon neutral
Okay.
places.
ठीक है, सक्सेना जी,
So
आप कुछ कहना
that
चाहें?
is
I'm sorry
one
to cut
thing,
you
yeah.
because I think we need to wind up also. So
Okay. So
Saxena
this
ji.
is, yeah, I'll
Yeah,
just
please
add
go
on
ahead.
few
Please
things.
go ahead, Glory. This is your time. So
Yeah.
please go
So
ahead.
another thing is the bricks that we use, the concrete that we use, those fly ash can be used into it. The bricks, they can have the fly ash product into it. The tiles that we use, they can be like the ceramic materials could be added, which is like 55% or 60%, something like that. Recycled materials can be added into it. Even the metals, these, they are also the recycled metals which can be added to it. All these things make the entire building component as a carbon sink thing. So these are the few things where, and these products are being supported by all the certification bodies also.
Great.
Yeah.
सक्सेना जी,
एक चीज मैं ये कहना चाह रहा था कि although building consume a lot of things where you can fix the car, in fact जो technologies आज की डेट में हम लोग ड्राइव करना चाह रहे हैं और what the other people are searching research पे जो, because I am also involved in few projects on that kind where we want to fix the carbon as a natural resources, like converting into inorganic material. Carbon can be fixed as a calcium carbonate, as Madhusudan Sahab said, what you will do with that calcium carbonate. But definitely calcium carbonate are used in a lot of places in industry and a lot of places. Rather, I'll say that nature also perform the, if you see the carbon cycle, carbon dioxide cycle inside the sea, you'll see that carbonic acid is first developed, then it reacts with the certain organic mass, उसको calcium carbonate के तौर पे निकाल के लाते हैं, and that calcium carbonate again joined with the plankton are consumed by the other छोटे जो कीड़े हैं जैसे शंख हैं, इस तरीके की चीजें से, that they deposit the carbon as a calcium carbonate, because all shells of all, just like an egg shell, all this is the biggest process taken up by the nature itself, which is producing calcium carbonate. Calcium carbonate is not a sludge which you can throw at anywhere. Calcium carbonate are used for a lot of places. Particularly, if I'll put it, चूना जो है हमारी इंडस्ट्री, बिल्डिंग इंडस्ट्री में भी बहुत जगह यूज होता है, right? We can go for the method like that. Anyway, I'm saying that there are other ways also. Particularly, industry is producing the maximum carbon offset. So what we need, like what my aim for my projects is, I just wanted to fix the carbon as much as possible and making some good product of it so that it can be sustainable by the industry. Like I explained you about the methane generation in Jaipur dairy. Right?
Yeah, I understand, sir.
Where you are using the energy out of that, because the energy was consumed by somewhere from the solar in only. Solar has produced the plant has been eaten up by the guy, or guy ne fir doodh diya, then again it generate the sun. So
yeah,
it is the same cycle.
Yeah, true. हमारे ना ये आज guests में एक अमित कुमार मित्तल जी भी हैं, and who's been like putting very cute suggestions. Amit Kumar Mittal ji, I know I cannot invite you to be, on the discussion right now, but for sure, one of the programs later on, we'll also keep you as a panelist, and so keep continuing to share your wonderful ideas. I don't know whether I don't see Rajesh Vig ji is there or not, But Dr. Varun Jain, can you please, on our conclusion part of it, like on the heat, carbon sink, can you throw some light on it, please? Can we actually do something?
Already our experts have mentioned about different technologies, but these are not at present available. As far as our commitment for this Paris Agreement on carbon sink is that we can only do afforestation to plantations. And the reason behind is that there is no proper funds which is provided on towards this, and we are already in 2021. So I believe getting that much 2.5 to 3 billion tons of CO2 equivalent as carbon sink by 2030 is not possible. But yes, we all need to start doing plantations and all, like DCI has decided. If there was no COVID, we could have planted 100 trees
True that, sir.
on this earth day.
Yeah.
So that's what my take is.
ग्रेट सो मैंने जैसे पहले भी कहा था कि आज मेरा सिर्फ एक ही काम है कि मैं एक सवाल से दूसरे सवाल में आप लोगों को सबको पैनलिस्ट को तंग करूं तो आई थिंक बिफोर वी पार्ट ऑफ माय एंड आई विल आस्क एवरीबॉडी ऑन द पैनल that we know that we need to offset the carbon footprint, that we know that there are technologies, that we know that there are limitations to adoption, that we know that there are challenges. But quickly I would like in like 1 minute flat from each of you कि आज जिस टॉपिक को हमने शुरू किया है आप इंडिविजुअली अगले 1 साल तक उसकी तरफ क्या करेंगे, right? So what is going to be Dinkar Saxena's effort, what is going to be Glory Srivastava's effort, what is going to be Amit Kaushik's? So I will just leave it to you. 1 minute each flat.
मैं तो पिछले 30 साल से यही काम कर रहा हूँ।
एक साल और क्या जोर लगाएंगे सर?
नहीं, डेफिनेटली जितना हम लोग ऑफसेट जनरेट कर पाएंगे उतना करना कोशिश करना, जितना भी कार्बन ऑफसेट, दैट इज द फर्स्ट थिंग। जो हमारी ग्रीन हाउस गैसेस हैं उनका एमिशन जितना कम हो या उनको यूटिलाइज किया जाए। जैसे
सर ये प्रोग्राम रिकॉर्ड हो रहा है सर, और अगले साल इसी दिन पे आप सबको चारों को बुलाएंगे हम पक्का। ठीक है। सो सतीश कुमार जी, व्हाट विल बी योर एफर्ट फॉर द नेक्स्ट 12 मंथ्स?
सर 12 मंथ्स के लिए हम सिर्फ यही कर सकते हैं कि ज्यादा ज्यादा पेड़ लगाए जाएं, इससे ज्यादा कोई ऑप्शन नहीं है। कंजप्शन किसी भी चीज की कम नहीं की जा सकती।
बहुत सही, बहुत सही।
कंजप्शन नहीं कम कर सकते, प्रैक्टिकली पॉसिबल नहीं है।
सही बात है।
कोशिश की जा सकती है, 4 लोगों को समझा सकते, साथ में लेकर लोगों को ज्ञान दिया जा सकता है, लेकिन प्रैक्टिकली 1 ईयर में तो नहीं होगा, बहुत लंबा समय लगेगा। लोगों को समझाएंगे साथ में, और एफर्ट जो खुद से कर सकते हैं वो सिर्फ यही है कि ज्यादा ज्यादा प्लांट लगाए जाएं।
वेरी गुड। ग्लोरी टू यू नाउ।
You have an architect with amongst you, जो कि पेड़ काटना उसका पहला काम होता है।
So what are you going to do different this year now, Glory?
So first thing, I think the architect fraternity, they have to be really, they have to be hell-bent कि नहीं, पेड़ बिना काटे what solution can be drawn out of it. So लगाएंगे तो सही, लेकिन जो लगे हुए पेड़ हैं which are like 100 years old, 30 years old, 10 years old, उसका replacement लगा के कभी नहीं हो सकता। So ना काटें, और उसके around we need to design our buildings and plant as many, और कोई भी building बनाए we should जितना भी हमने उसका replacement करा है, जितना भी हमने land का dishonor किया है, उसको हम replacement within that fraternity, terrace पे करें, कहीं भी balconies में करें, we should compensate it some or the other way.
Very great, very great. Varun ji, now leave it to you.
It's a good question that what we all individuals are going to do for next 1 year. I would only say, like Glory ji said, that in architectural design, she will try to incorporate in a way that we uses the emission of greenhouse gases are less. Similarly, that's what I can do as a design engineer, convince my client to go more of energy efficient design. The main roadblock is the payback period. In the industry, we say 3 years payback period hai, so we'll do it. otherwise 3 years or less hai, otherwise will not opt for that energy efficiency design. So that is something is a roadblock. Second thing is the aesthetics. Yes, matters. Jo dikhta hai, wo bikhta hai. But still, energy efficiency and aesthetics both should be amalgamated so that the building should be now more seen as net zero energy and less emission of greenhouse gases.
Great. I see Rajesh Vigji is back. Rajesh ji, can you speak? I mean, like, we haven't heard you the whole evening today. So I think there's still communication problem. Oh, I think to conclude on DCI part, we have taken carbon neutrality as the year-long agenda. तो हम आज नहीं और आज से लेके अगले साल इस दिन तक हम sensitize करेंगे. We will try to bring this topic more on the table for discussion, whether it's on the side of problem, whether it's side of solution, whether it's side of technology, whether it is side of public partnership, private partnership, into transparent efforts like planting trees and going green, and then again by using recyclable products. There are plenty of things that DCI has on its own taken as an agenda for this next 12 months. And I thank you all the panelists for taking your time today. And it's gonna be soon the time to switch off the lights. So I request everybody to follow the schedule. Let's honor the day today. Thank you all. Thank you again, everybody. And I would leave this session now to Amit Kaushik ji. Thank you so much.
Yeah, good evening all. Myself Amit Kaushik and I am Chair Advocacy, Delhi Chapter. So today we had a very wonderful session on Earth Day. We learned so many things and we had a very good panel discussion also followed by that. So let's try to implement these things in our day-to-day activities, in our personal life, in our professional life, whatever we have learned today. And like this, we will enrich our knowledge in future also. So we would like to thank our speaker, Mr. Madhusudan Rao today, who gave us so many things on this carbon neutral, our moderator, Dr. Varun Jain, and our partners, our gold partners, ALP Aeroflex, our annual partners, Standard Refrigeration, Fluke, Advanced Walls, Luby Industries, Lloyd Insulations, and our membership partners, Aircon Engineers. So we also like to thank our DCI president who is not here today due to some personal reasons, Mr. K.D. Singh, our president-elect, Mr. Ashish Gupta, and our Lucknow president, Glory Srivastav, our panelist, Dr. Dinkar Saxena ji, Agra president, Mr. Satish Kumar and Mr. Rajesh Vik from Mayor Subchapter. And last but not least, our all audiences. Thank you. Thanks to all. And have a good evening. Thank you. Good night. Thank you.
Thank you very much.
Thank you. Thank you, everyone.
Thanks for inviting us.
Yeah, sure. Thank you.
Thank you, everybody. Thank you very much.
Thank you, Amit ji.
Thank you. Thank you.